Today I'm going to talk about sorting lists in Python. Lists can be very simple, like a list of integers, to more complicated, like a list of custom objects or tuples or dictionaries. We'll take a look at both of these today. Sorting data is a very common operation. No matter what you're working on, I'm sure you can think of at least one use case of sorting. Python gives you some very handy functions that you can use to sort efficiently. You can even chain sorts so that for the same data, you have a primary sort and then a secondary sort within that. There are quite a few complications you can add depending on your use case. So without further ado, let's get started. At first, we're going to look at the most basic case, which is going to be a list of numbers or strings. The two primary ways you can sort in Python are the sort method that comes with the list data structure and the sorted function, which takes in any iterable. So let's say we have a list of numbers, which is going to have a random unsorted list over here. And let's have a list of strings. Gonna have again a random list of strings. There you go. And let's use the first approach, which is gonna be invoking the sort method in the list data type. So let's just print out our original list, sort it, and then print out the same one again. As you can see, at first we're printing the unsorted one, and then for the same list, we're printing the sorted one. That's because when you're invoking the sort method, the sorting is being done in place, so you're replacing your original list. Let's try using the sorted function now. So we're gonna keep printing the original one, but now what we're gonna do is we're gonna call this new function here and pass it our list of numbers, and then print out the new list that we're getting. There you go. Okay, so as you can see, we are printing our original list, and similar to the last time, we are printing the sorted version of the list. Both of the approaches will sort your data in ascending order by default, but there's a crucial difference between these two approaches. The sort method performs the sorting operation in place, so you end up replacing your original list. The sorted function, on the other hand, performs the sorting operation out of place. That means it returns a new list, sorted numbers, that has your sorted data and leaves the original list untouched. This way you can use both if you need to. The only place you want to use the sort method over the sorted function is when you have a huge list and you know you won't need the unsorted version of it. That's because by doing the sorting in place, sort avoids the memory overhead of creating an entirely new list. It can only have performance implications if your lists are seriously huge. Otherwise, you always want to use the sorted function, as it's more functional and deterministic. You're less likely to run into any bugs if you're not mutating existing data structures. As said before, by default, Python sorts your data in ascending order. If you want descending order, you can just pass in an argument to the function called reverse. So let's take a look at that. So let's run this one again. And as you can see, your sort is in ascending order, so from smaller to bigger. Let's say you want the sort to be in descending order, which is from bigger to smaller. All you do is pass in an argument, reverse, and then set it to true. Let's try to run it again. As you can see, the sort is now in descending order, so we're starting from 80 and going down to 10. We can also do the same thing for our list of strings. So let's just do that one. Let's call it sorted strings. And then let's give it our list of strings. We want to do it in ascending order first. So let's remove the argument and print out both. So there you go. So we want to print out sorted strings. And we want to print it out here too. There you go. That should work now. So the first we're printing the original one, and then we're printing the sorted one in ascending order. Now, as we talked about before, if you want this to be in descending order, you can pass it reverse and set it to true. There you go. This way, you're gonna get D, C, B, A, so you're going from bigger to smaller according to the ASCII values. Now let's look at slightly more complicated lists. What if your lists contain tuples or dictionaries? So let's take a look at both of those. We're going to remove our current examples, and let's say we have a list of data points. Each of the data point is a tuple. We're just going to have some random data here. Then the last one, we're going to have 20, and there you go. Let's see what happens if we sort this list of tuples in the same way we were sorting a list of integer and string. So similarly, we're going to have sorted data, and then we're going to pass our list to the function. And let's see what's happening. And let's print out our sorted one. There you go. Now let's see what's happening. As you can see, the sort is being done based on the first item in your tuple. So this is the default behavior. Python is sorting the tuples based on the first element in the tuple. That's why you see 10, and then you see 20, and then you see 40. Let's say you wanted to sort by the second element instead. What do you do? In that case, you can use the key argument, which takes in an anonymous function or lambda. So let's take a look at that. So just like we passed the reverse argument, we want to pass it a key argument. And then we want to pass this an anonymous function, or in Python, we call it lambda. So we do lambda, it takes in the argument x, which is going to be the current item. And you want to define which element within that item you want to sort by. So let's say we want to sort by the second element in the tuple, which is going to be the first index. And let's try running it. Now, let's see. So we're getting the tuple with A at first, B, and then C. The lambda function takes in the current tuple as an argument. So you can choose whichever item you want to sort on within the tuple. And let's say the same thing, you want to do this whole sorting in descending order. So you do the same thing that we did before, where we just pass it a reverse equals true. And let's clear it and then run it. And as you can see, we are doing C, B, and A. So our list is being sorted in descending order, and the sort key is the second element in each of the item. Dictionaries work in a very similar way. So let's take a look at that. So let's say we have a list of employees. So we're going to have, okay, there you go. We have a list of employees, and then we're going to have the first is going to be a name. Let's say we go with Max. And then let's say each employee has an ID. And then let's say the ID is 30. And then we have a few more. Let's have like 3. So we're going to copy paste it 2 times more, and then just change the data. So let's say our next employee is John with an ID of 20. And let's say our next one is Ben with an ID of 100. So we can do Ben with an ID of 100. There you go. And let's sort it the same way we were sorting it before. Let's call it sorted data. And we call the sorted function and pass it our list of employees. And let's print out our sorted data. There you go. we're running into a type error. So we can't, by default, compare a list, sort a list of dictionary objects. That's because Python does not know how to compare two dictionary items when sorting. So you have to explicitly tell Python which attribute in the dictionary you want to sort on. So let's see how we want to do that. So let's say we want to sort our list of employees by the ID. So you do it very similar to how you did for the tuple. So you just pass it the key and give it a lambda function. But to the lambda function, you can just give it whichever attribute you want to sort on. So for our case, we want to do it by ID. Now let's run it again. As you can see, now we are sorting the list based on the ID. So we're getting 20, 30, and 100. You can do the same thing based on the name. So we can just do the sorting based on the name. That way we get Ben, John, and Max. So B, J, and then M in ascending order. For the same, if we wanted to do sort in descending order, we could have just done this. And we got the reverse order that way. So that is how you sort a list of tuple or a list of dictionary items. Now let's take a look at a list of custom objects. It's pretty common practice in Python to create classes to hold data. We can have a list of these objects and you might want to sort them in different orders. So let's take a look at that. We're going to create like a sample class, which is going to be car. We're going to give it an initializer and then give it 3 attributes: registration, wheels, and color. And then let's just do the instantiation. We do wheels, and then we do color. And let's also give it our wrapper function so that we print out something that is readable. Otherwise, we'll be printing out like a memory object, which we cannot read. So we're just going to return a formatted string. So the formatted string is pretty much going to be all our attributes so that we can easily read them, separated by commas. There you go. And then we have the last one, which is going to be the color. There you go. Yeah, and then what we can do now that we have a car object, let's create 3 car objects. And then let's just give it some random data. So let's say the registration number is 10, number of wheels is 2, and then the color is blue. Let's copy paste it 2 more times. This is going to be our car 2, which is going to have a registration number of 100. And it's going to have 4 wheels. The color of the car is going to be red. For the last one, we're going to have a green car that's going to have 1 wheel. And then the registration ID is going to be 70. So it's pretty straightforward to sort these objects if they were in a given list. So let's create our list here. So let's just call it cars list, which is going to be car 1, car 2, and then car 3. And then we want to rename this to car 3. There you go. Okay. Let's see. Yeah. So the process to sort this list is almost the exact same as the one we discussed before. You just define the attribute you want to sort by using the key argument. So just as we did before, we want to do sorted. Let's just name it something different. We want some more space here, and then let's come here. There you go. So let's do cars by registration. This is going to be sorted by registration. We want to do the cars list again. And then we want to have a lambda. And then we just want to do let's say we're doing it by registration, so we just want to do this. And let's do cars by wheels. Same, we're going to pass in our list, and then we're going to pass in a key. That is going to be a lambda function, and we're going to choose the attribute wheels. For the last one, we're again going to pass it, and then pass it the key, which is going to be a lambda function with x.color. And now let's print out all three of them. So let's do cars by registration. Let's do cars by wheels, and then let's do cars by color. There you go. Okay, so let's take a look at this. What's happening here is we are printing each item as like, actually, let's just do this. Instead of the separation being comma, let's separate by dot so that we know the distinction between one item and then the separation between each of them. Okay, let's run it. There we go. Okay, that's better. So the first one is where we're sorting by registration. So we can see we're getting 10, 70, and then 100. So the list is being sorted by the registration number in ascending order. For the second one, which is going to be sorted by wheels, the second attribute is the wheel. So we can see 1, 2, 4. So this list is being sorted by the number of wheels. For the third one, which is we're sorting by color, we're doing blue, green, and red. Let's do the color in the reverse order. So, and then run it again. There we go. So there you go. If we do it in the reverse order, we're getting red, which is R, green, which is blue, green, which is G, and then blue, which is B. So we're doing it in descending order now. So as you can see, sorting lists of objects is very easy as long as you define the class attribute that you want to sort on. Okay. So we're sorting the same data 3 times in 3 different orders. As you can see, we have each of our sorted lists correctly sorted depending on the sort key. Whatever you learned up till now is the fundamental you need to do any kind of sorting on your data structures. However, Python has some utility functions you can use to make your code even cleaner and your sorting more powerful. Let's take a look at that now. So for that, what we're going to be needing is, I'm going to get rid of that. So you're going to be needing the operator module, and you want to get ItemGetter and AttributeGetter, I believe. Okay. Is that right? Yeah, we have ItemGetter and we have AttributeGetter. You can use Python's operator module. So we have to give it import. Yeah. So you can use Python's operator module to define your sort keys more cleanly and chain together multiple sorts. You can use the ItemGetter function that we have over here to define which element you want to get from a tuple. This makes the code much cleaner and easier to read. So let's remove everything we had up till now. And what we're gonna do is we're gonna let's see, we're gonna have our data points again. We're gonna do something different now. Let's just do 50, C. Let's do 10, B, and then let's do 20, D. There you go. That's a list of tuples, and let's sort it like we were doing before. There you go. Let's give it our list of data points. And now let's see how we can use ItemGetter to make our code much cleaner. So with ItemGetter, defining the sort key becomes as easy as doing ItemGetter, and then just defining the index of the element that is going to be your sort key. So this tuple has 2 elements in 0th position and then 1st position. So let's do it by 1. So we want to be sorting by the 2nd element over here. And then let's try to print it out. Okay. So we're doing B, C, and D. So as you can see, we're sorting in ascending order by the 2nd element. If you wanted to, let's just put like a 3rd element in each of these tuple. So let's say we have 100, we have 300, and we have 200. And this is going to be the 0th, 1st, 2nd element. So you can just do 2nd. Then, as you can see, we're doing 100, 200, and 300. So ItemGetter makes it very easy and very clean when you're defining which element of the tuple or dictionary you want to be sorting by. Similarly, if you're sorting a list of objects, you can use the AttributeGetter to define which attribute of the object you're defining as the sort key. So I'm going to bring back the cars code that we had. So let's just get rid of all these. So we had our car here. Yeah, okay, let's keep the operator one, the attribute getter that we're going to use. Just to recap, we have a car class with 3 attributes: registration, wheels, and color. We're creating 3 car objects. We're creating a list from those 3 car objects, and we were sorting by registration, wheels, and color separately and printing all those 3 out. Let's save it, and then so yeah, as you can see, we're doing by registration, wheels, and color. As you can see, this right now it doesn't look very bad. But when we have more complicated objects and we have nested attributes, you can see this code getting messy very, very quickly. And also, like, defining a lambda function doesn't look the cleanest. So let's see how AttributeGetter can help us do that. So for each of these, what you can do with AttributeGetter is you can call the function and literally just name the attribute that you want to sort on. So it's just going to be registration. I'm going to copy, actually no, let me just do it from scratch so that it becomes easy to read. So let's get rid of these. Then you want to define a key, do the attribute getter, and then just name the attribute you want to sort on. So key, attribute getter, and then the sort key. Here you go, and we're printing out the 3 again. Print it out. As you can see, we are getting the same order that we got before. This time the code is just cleaner and easier to read just by glancing at it instead of looking at the lambda function and whatever the lambda function is doing. The coolest thing of using the operator module is that you can chain together a bunch of sorting to have your data exactly the way you want it to be. Let's say you have the cars data just as you had before, but then what you want to do is after you sort that list by registration number, within that you want to sort by wheels. So if 2 cars have the same registration number, the order within those 2 is going to be by wheels. So let's see how the operator module helps us do that. So we're going to introduce a new car here, which is gonna be registration 10, so that we have 2 cars with the same registration number. And then wheels, let's give it a different number of wheels. Let's give it 1. And then let's give it a new color. There you go. Okay. And now let's get rid of these. We don't really want these. And let's just clean some of these to make things clearer. In our list, we want to add the new car. There we go. And then, so now we have a new car, which is the same registration number as car 1, but it has wheels as 1. And then let's do the sort. So it's going to be cars by registration, then wheels. Going to do sorted. We're going to give it our list. And then this is where the trick comes in. We can use our AttributeGetter, and then we were doing registration. But now what you can do is you can just chain together whatever number of attribute you want. So we do registration and wheels. Okay, and then let's print it out. And let's see what we got. Okay, so we get, so remember we're doing the, we're sorting by registration first. So we see 10, 10. So we have two cars with 10 as the registration ID. We have 70 and then 1000. But within the 10 registration ID, we have 2 cars, and you can see those are sorted by wheels. So we have the first car with wheel 1, and then we have the second car with wheel 2. What happened if we wanted the sorting to be in descending order? So if we do reverse equals true, let's see what happens. So now you can see our cars that has a registration ID of 10 is at the end. But when we're sorting within those 2 cars, we're sorting by wheels in descending order. So you get 2 and then 1. As you can see, it's very easy to chain together multiple attributes so that your sorting becomes as chained as you want it to be. And chaining is super easy this way. So you can chain as many sorts as you want to get the data exactly the way you want it. The operator module also makes sure that you're doing these multiple sorts in the most efficient way. So yeah, there you go. That's pretty much all there is to sorting data structures in Python. Now you should be able to sort and present your data in whatever order you want to. Hopefully you learned something new from this video. If you did, please like and subscribe. I'll catch you in the next one.